All right, hi, this is Mr. Hebner. This is during the pandemic of 2020. That's why I'm wearing a mask. I don't normally wear a mask otherwise. What we got going on today is looking at doing redox reactions, looking at a balanced equation and trying to determine what the half reaction oxidation is and what the reduction half reaction is. All right, guys, ready? So right here is iron plus oxygen forms iron oxide, and we have to first determine what is oxidized and what is reduced. But in order to do that, we first need to determine what the oxidation states are. So if you have a metal that's solid, what would the oxidation state be? 0. You got it. So anytime you got a diatomic element or a like a monatomic element like a noble gas, or a metal that's solid, it's 0. Or you could have a gaseous metal, it would still be 0. So anything that's monatomic. So O2, what would that be? 0. 0. All right, and then we got Fe2O3. We don't know what iron is. It could be +2, +3. It's a transition metal. But we know oxygen is always -2, unless it's peroxide, but that's definitely not peroxide. All right, so then context clues, -2 times 3 is -6. Therefore, our overall charge of iron's got to be +6. But there's 2 of them, so 6 divided by 2 is 3. So, looking at iron, we're going from 0 to +3. What's happening? Close. So close. It's not gaining electrons. It's losing electrons. There you go.
Yeah. Sorry, for some reason I forgot that electrons are good.
Yeah, it's super confusing because it's kind of opposite. I always think of reduction as getting lower in number on the number line, but you're actually gaining electrons when doing that. So oxidation is losing electrons, and the number gets bigger. So iron, here I'm just going to do this right here, oxy for oxidation. And then by default, we could probably assume that oxygen is being reduced. But just double checking, we're going from 0 to -2. Number getting smaller, more electrons being added. That's reduction. So now what I'm going to do is I'm going to do my oxidation half reaction. Just labeling it. And we started with 4 irons. And that's solid. And we ended with, technically what we're going to do is we're going to break this up. There's no state of matter here, so this is either a solid or aqueous. But we're going to say 2 times 2 is 4. And they're +3s. And I'm not labeling it because they didn't do a good job labeling it, so we can't determine. But essentially that's it. Then we got to draw where the electrons are going to be. And if this is oxidation, electrons are being lost. So do you think it's a reactant or a product? Product, you got it. So electrons being lost, and we got to figure out how many electrons were being lost here. It's going to be 3. But technically there's 4 irons, each with 3 being lost. 12. So 12. I believe that's correct. Double check. Glad we're doing the video today because I made all the mistakes yesterday. So it should be 12. Oh, and an E. E minus 4 electrons. Alright, so next we got to do reduction. Any questions so far? Alright, so then we've got reduction is oxygen. We're starting with 3. So if electrons were a product on the other one, they're probably going to be a reactant. So let's do myself a service and give myself some space. Alright, 3 O2 and gas, and it reacts to form 6 oxygens, each with a -2. And again, I don't know what state of matter is, so I can't write it, otherwise I would. Alright, so we got 3 times 2 is 6. Oh, wait, no, I got more than 3. I've got 2 times 3 is 6, so I got 6 oxygens, each of them with 2 electrons. So how many electrons are being given? 12. You got it. 4 is a good alternate possibility. So 3 times 2 means I got 6 oxygens, each of them with a -2, so that's 12. And I'm gaining them because it's reduction, so I got to show 12 electrons as a reactant being gained. Yeah.
So for the product side in both of those, I noticed you moved like so like instead of O3 you have 6O. Why is that?
So basically these are ions, and they're coming together in a compound, so you want to show all the individual ions. And again, typically you have like aqueous. If it's aqueous, definitely it's an ionic compound. It is, yeah, it is ionic if it's aqueous. Yeah, but for example, I gotta revamp it just so it's more specific. And this next one is just as, oh no, the next one's a little bit better because they have it. Yeah. All right, so let's move on to the next one. The only problem with this one is I don't have a lot of space, so I'm going to just do that. There's some space. First thing we do, write the oxidation state. I know oxygen is always -2 times 3. There's 6 of them, or there's a charge of 6, therefore my irons have to be 6, but there's 2 of them. So let me show this. 2 times 3 is -6, so my positive must be +6. Divided by the 2 irons is +3. Questions on that? How about carbon? If it were an ion, 0, you got it. So if it's in an elemental form, monatomic ion, or if it's a monatomic element or a monatomic ion, well, if it's monatomic, it wouldn't be an ion. So yeah, 0. How about iron? 0, monatomic. And then 3CO2, oxygen's -2, and there's 2 of them, so 2 times -2 is -4. Therefore, carbon has to be +4. And carbon can be plus or -4. In this situation, it's going to be +4. So then we can determine, why don't we just see, iron is going from +3 to 0. What's happening? It's reducing, you got it, because it's gaining electrons, it's becoming more negative, it's being reduced. So, tricky. So we'll call this reduction. And then oxygen's going from -2 to -2. We call that a spectator. Doesn't really do anything. And carbon's going from 0 to +4, which is oxidation because it's losing. Alright, then we got to draw our half reactions. Starting with, let's do the iron. We've got 2 times 2 is 4. So that is 4 FEs, and each of them are +3. I guess we could write the solid. And then what else is happening? It is turning into 4 Fe. In this case, solid with a 0. Next, we got to determine where the electrons are, and we're dealing with 3 electrons being transferred per iron, but we have 4 irons. 12.
Nice job, Ben.
There we go. So when something's being reduced, it's gaining electrons, so we call that a reactant or a product. Reactant. So I got to put it right here. 12 electrons. Next one, oxidation. Oh, we'll label this as reduction. And we'll label this next one as oxidation. Okay. We're starting with 3 carbons. And we're ending with 3 carbons. Let's see, 3 carbons. Oh, plus 4. And when something's being oxidized, it is losing electrons. And we're dealing with 3 times 4 is 12. All right. Could you have a situation where the number of electrons being oxidized is different than what's being reduced? Yes. What does that mean you got to do then? Then you got to balance it. So you'd have to multiply everything by 2 or whatever number to make these electron amounts and reduction and oxidation match, which I believe is what we'll be doing next Tuesday. So, all right. Okay, so getting into some concepts, we got reducing agent and oxidizing agent. What this is it's talking about like what is oxidized is facilitating the reduction of something else. So a reducing agent is the substance that is oxidized, and I want to make sure I got enough ink in my pen for next period. So here we go. So causes reduction by giving up electrons is a reducing agent. It's the substance that undergoes oxidation. The oxidation number of the atom will increase because it's losing 1 or more electrons. So if you can just think that what is oxidized is the reducing agent, and what is reduced is the oxidizing agent, because they facilitate the opposite. Whereas oxidizing agent causes oxidation by accepting electrons, gains 1 or more electrons, becoming a more negative oxidation number, because it undergoes reduction. In general, metals are reducing agents. They lose electrons, and then nonmetals are oxidizing agents. Gain electrons, it's not always the case, but that's the majority of the time. So I guess when you're talking about redox reactions, something that is oxidized has 2 names. It's the substance that's oxidized, and it's the reducing agent. Kind of like James Bond has a couple of names. One is James Bond, the other is 007. Not the best analogy, but you know, something. Oh my gosh, we only got 4 minutes, so write quickly. All right, well, let's move. Oh my gosh, what happened to the time? We're out at 25 after, right?
Yes.
Oh man, how did that happen? Okay, so we're good?
Yeah.
Okay, moving on. We got to do the whole kabit and caboodle here. We got we got to first eliminate the spectator ion. So the ion that's not changing, and it might be better just to figure out what's oxidizing and what's reducing. So zinc is 0. Gold, I'm not sure what gold is, but I know nitrate's -1. I just memorized it. Nitrate's -1. If you don't know that, you can look at, okay, oxygen's 2 minus, and there's 3 of them, which is -6. Let's see. Oh no, yeah, you'd have to know that. You just have to know some of these. Polyatomic ions, nitrates -1. Yep, those polyatomic ions memorized last year. Rememorize them. Well, I'll send you a list.
What do you mean?
But anyways, there's -1 times 3 is -3, therefore gold is +3. Gold, when it's in the elemental state, 0. And nitrate, again, is -1. There's 2 of them, so that's -2, so therefore zinc's +2. Alright, so then we know zinc's going from 0 to +2, alright? 0 to +2, that is losing electrons, therefore it is oxidized. And then gold is going from +3 to 0. +3 to 0, it is becoming less and less, more and more negative. It's gaining electrons, therefore it's reduced. Nitrate is doing absolutely nothing. It's -1, and then it ends at -1. So it's a spectator. Yep. So spectator ion, I'm going to eliminate those, and I'm going to rewrite the equation. And again, you can do this a lot quicker. Like, you don't have to rewrite the equation. You can just write the half reactions. But for the sake of notes, we rewrite the equation. Plus 2Au, 3 plus aqueous, and then we've got 2Au gaseous, 0, plus 3 zinc, plus 2, and I'm just going to assume that's aqueous. Actually, no, I'm not assuming. I know that anything that's a nitrate is aqueous, because I know my solubility table. Alright, so then we already identified what was oxidized and what was reduced. So separate into half reactions. Let's do the zinc. We got 3 zinc, 0 charge, it's a solid, and it is turning into zinc 2+, and we've got 3 of those. +2, sorry. Oxidation state, positive, negative first. We'll just assume, yeah, that's aqueous. Alright, so this is our, I'm just going to keep on going. If you need to go, that's fine. And I'll pop this video up on Canvas tonight. Oh shoot, is that oxidation? It was, thankfully, because I wrote oxidation. And electrons are being lost, therefore we've got 3 times 2 is 6. So 6 electrons being lost. And then reduction is gold. We got 2 gold, aqueous. And then the now you try is your homework for tonight, so you can try that one. And then we've got, let's see, gold is, there's 2 of them, it's a 0 charge, and it's gas. Oh, this one's +3. +3 times 2 is 6, we got 6 electrons being transferred. We know this is reduction because it's being reduced, lower number, and there's 6. Hey, I don't have to do any fancy balancing because there's 6 electrons lost, 6 gained. And there we go. Oxidation reduction. Hopefully you enjoyed this video during the 2020 pandemic.